Okay, Mishler Math is back, and we're going to look at some quadratic equations in one variable. Okay, so we're going to solve by taking square roots. Okay, and we're going to use a Pythagorean theorem to solve problems with right triangles, because after all, those are quadratics as well. So let's take a look. Suppose x squared equals a. Well, first of all, if a is less than 0, then there's obviously no real solution, because if you square a number, you're going to get a negative times a negative is a positive, and a positive times a positive is a positive. So if a is less than 0, you can't have x squared equals -9, because what two numbers do you multiply together to get -9? You can't multiply the same two numbers together and get a negative number, because if they're both negative, you're going to end up with a positive. So anyway, enough of that. If a is less than 0, there's no real solution. If a is equal 0, well, then x equals 0, of course. X squared, if x squared equals 0, then x equals 0. Okay? But if a is greater than 0, then x is equal to plus or minus the square root of a. For example, okay, let's take a look at x squared equals 9. Well, x is equal to 3, but x is also equal to -3, because -3 squared is equal to 9, isn't it? -3 squared equals 9. Okay, so if x is equal to -3, then if x equals 3, then they're both equal to 9. I hope you understand that and get that, because we're going to move on from here. Okay, so, and also remember that you've got some, we talked about some radical properties. If the square root of a, if you have the square root of a times b, that equals the square root of a times the square root of b. Okay, and if you have the square root of a over b, that equals the square root of a over square root of b. Now, everybody get that? I'm pretty sure we covered this, but if we haven't, then just realize that that's the case, because we're going to need that for simplifying some of our radicals. And let me tell you what I'm talking about now. Let's suppose we have 5x squared minus 19 equals 231. Okay? Let's try this one first. Now, the first thing I'm going to do to solve this is add 19 to both sides. And I get 5x squared equals 250. 19 plus 231 is 250. Now I divide both sides by 5. And I get x squared equals 250 divided by 5 is 50. Okay? And so x equals plus or minus the square root of 50. You say, well, can I leave it there? No, you have to simplify. You must simplify. And what do you mean by simplify? Well, 50 is equal to 25 times 2, isn't it? And of course it is. So x then is equal to plus or minus the square root of 25 times 2. Now, by the rules of radicals we just talked about, that means x is equal to plus or minus the square root of 25 times the square root of 2. But that equals plus or minus 5 times the square root of 2. And let me go over that again, okay? If you got the square root of 50, that's the square root of 25 times 2. Okay? Which equals the square root of 25 times the square root of 2, which equals 5. The square root of 25 is 5 times the square root of 2. And so, x squared equals 50, x equals plus or minus the square root of 50, and which equals plus or minus 5 times the square root of 2. This is a simplified answer, and you need to simplify. Okay? And you can't, now some of you are going like, Well, duh, I just get my calculator and I'm going to go square root of 50. And let's see, square root of 50. And there, done. Except, look, it just keeps on going here. There's a decimal that keeps on going. And 5 times the square root of 2 is approximately equal to 7.07. It's not exactly. This is an exact answer. And if it says give me an exact answer, I need the answer in radical form. But there's another way of solving this, and I'm going to show you this. This is kind of cool. Okay? Now look at what we have here, and use a different color here. This is going to be my y1, and you've seen me do stuff like this before. And this is going to be y2, and I'm going to find the intersection of these two. So let's see what we have. Okay, so we got y equals 5x squared minus 19. Now, by here you're saying, well, why don't I just do x squared equals 50? Put x squared on one side and 50 equals, because obviously I could have made a mistake in my calculations here. So I always go on and go back to the original one. So 5x squared minus 19, and down here I put 231. Now this is a real good case of making sure your window is where you want it. If y2 equals 231, and I go with a negative 10 and a positive 10, obviously I'm not going to have my window where I want it. So I'm going to make my y max. This is 231, so I'll make my y max at 250. Okay? And if I make the y scale at 1, I'm going to have too many, I don't have enough pixels there to do that. So I'll make the y scale, let's say at 50. That'll work. You know, that'll give me 5 notches. You know, 250 divided by 5. And I think my x scale ought to be okay. So let me see if I can graph that and get both of what I need. Okay, there's my parabola, and there's my constant, y equals 231. Remember, I'm looking for the intersection of these two lines. So let's see what I find. Okay, second calc, intersect 5. Move my cursor. Look at where my cursor is. You see the cursor right over there coming up? Okay, enter, enter, and enter. And there's one of my intersections at negative 7.07. That's an approximate answer, remember. So negative 7.07 is one of them. And look at the other one is second calc. Number 5 is intersect. I want to find out where these two lines intersect. Now I'm going to move my cursor all the way over to the right, because it's going to give me the intersection that's closest to where my cursor is. This is not a case where it's going to tell me to pick a range. In this case, I have to move my cursor close to where it is. And I click enter, enter, and enter, and that gives my intersection at positive 7.07. So at positive 7.07. And we already did this on the calculator, and that is pretty close to what I have here. Remember, this is rounded, okay? And this is exact. This is exact answer, and this is approximate, because it's approximately equal to negative 7.07 or positive 7.07. Okay, I hope I've made my point. So let's try another one here. And this one, this says solve 4 times x plus 2 quantity squared equals 49. Now here I'm going to use algebra to start with. To start with, I'll divide by 4. Okay, and I have x plus 2 quantity squared equals 49 over 4. I don't see any way to reduce that. Okay, so now I'm going to find the square root of both sides. So I have x plus 2, because the square root of x plus 2 quantity squared is x plus 2. And I have to go to the plus or minus root here. And 49 over 4. Now, some of you probably figuring out that this is actually plus or minus square root of 49 over square root of 4. And the square root of 49 is 7. So I have 7 over square root of 4, which is 2. And so if I add or subtract 2 from both sides here, I have x equals plus or minus 7 halves minus 2. And that equals plus or minus 7 halves minus, now 2 is equal to 4 halves, isn't it? So 4 halves. So let's see what that ends up being, okay? Plus 7 over 2 minus 4 over 2. That's just 7 minus 4, which is 3 over 2. And then minus 7 over 2 minus 4 over 2. Negative 7 and negative 4 is a negative 11 over 2. So there's my two exact answers. And once again, I check it on my calculator and see what I get and end up with here. Go to Y editor and say, let's see, put on the left side, I go 4 times the quantity x plus 2 quantity squared. Okay, and down here I've got 49. Now I've got to change my window again and delete that 1 there. I don't want that. So I got to change my window again because now I want this y to go up to 50. Just 50 would give me enough space. And I can change this to make it 10. And by the way, y scale, that just means where does it put a notch on the scale. Okay, so let's graph this and see what we end up with. Okay, there's my parabola. There's my horizontal line. And now I'm going to find the, calculate and find the intersection, number 5. Move over here. And first find the next, this one here. Enter, enter, enter. My intersection is negative 5.5, and sure enough, that's 11, negative 11 over 2, negative 5.5. That's the same thing. And then find the intersection again here, calculate, and number 5 is intersection, and move it over here, and enter, 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 and 1.5, 3 halves. Okay, so that's how you do that. And now, of course, you're going to have some questions on this, and we'll ask those in class. Now, finally, we're going to use the Pythagorean theorem. And let's suppose I have a triangle here. And I'm learning my lesson about building stuff here. I'm using my tool to draw straight lines because you guys have had enough crooked lines from me. Now, this is a right triangle. And let's say this is 2.5. And this is 8.5. Well, I'm going to use a Pythagorean theorem, which is a squared plus b squared equals c squared. Now remember, c squared has to be the hypotenuse. And the hypotenuse is this side here, it's the longest side, okay? So I'm going to turn this into a quadratic equation like I had before. And so a squared, let's call this one a and this one b, okay? Oops, sorry. This is c, this is b. Okay, so I don't know what b squared is. So I'm going to put a squared, which is 2.5 squared, plus b squared equals 8.5 squared. Okay, so to find b squared, I have to subtract 2.5 squared. So b squared equals 8.5 squared minus 2.5 squared. Okay. No, that's not equal to 6.5 squared. Please don't go there, okay? So b is equal, now I can get rid of the plus or minus because we can be relatively, safely assume that b is not going to be a negative number. So all I have to do is use my calculator to find this thing here, and 8.5 squared, go back to the, clear this, 8.5 squared minus 2.5 squared, and enter, and we have 66. Okay, but we have to find the square root of that. Okay, so the square root, actually I can do square root of what I had before. Stop. insert square root, there, and close that, and that's the square root, approximately the square root of 66. So if I find the square root of 66, well, that's I don't know if I can simplify that. I don't see any. That's 11 times 6. I don't know if I can simplify that, so I'm just going to say approximately equal to whatever my calculator readout was, which is 8.12. 8.12. Now, there's a story about Pythagoras. He wanted to find a right triangle that had sides that were not decimals. You know, in other words, whole number sides. And he could never find it, and they say he went crazy trying to find that. So don't go crazy trying to find answers to this stuff, but, you know, learn how to do it. Okay, and we're going to have an activity we're going to do in class, and have a great day. Thank you.